All right, so today we are going to prove that lines are parallel. All right, so we are doing the reverse of what we had just been doing. So the last section, section 3.2, said, first off, again, think of if-then statements. All right, so if lines are parallel, cut by transversal, then corresponding angles are congruent, right? Well, now we're going to flip that around. We're going to say, well, if corresponding angles are congruent, then the two lines cut by transversal must be parallel. Okay? So it's just the converse of what we did the days before. Remember that converse idea from Unit 1. So let's take a look here. We have our four postulates and theorems. So the first one is a postulate because it is the converse of our corresponding angles postulate. And again, a reminder, converse just means that we're flipping the if and the then. So now we're saying if corresponding angles are congruent, then the two lines must be parallel. Because that is the only time that happens. All right? If corresponding angles are congruent, then the two lines are parallel. The converse of the alternate interior angles theorem. Again, if our alternate interior angles are congruent, then our two lines must be parallel. And that's how all of these theorems then work. If same side interior angles are supplementary, please remember that's the oddball one. It's different than the rest. If same side interior angles are supplementary, then our lines are parallel. And lastly, if alternate exterior angles are congruent, then our two lines must be parallel. So confusion arises on when to use parallel lines versus not to use parallel lines, or not parallel lines, excuse me, converse or not the converse. You need to remember that if you are given parallel lines, prove congruent angles or supplementary angles by the postulates or theorems. Okay? If you're given parallel lines, then prove congruent angles or supplementary angles using postulates or theorems. If you are given congruent angles or supplementary angles, and you're trying to prove parallel lines, that's when you use the converse. Okay? That's when you use the converse, is when you are trying to prove the lines are parallel. If you're given the lines are parallel, that's just those straight postulates or theorems from the last 2 days. Okay? So please keep that in mind. All right. So let's then take a look at some examples here. So we want to identify some parallel lines. We want to know which lines are going to be parallel if we are given that angle 6 is congruent to angle 7. Which two lines must be parallel then? What do we think? Not A and B. It's going to be L and M. Looking at those two lines, again, what type of angle pair do we have? Those are corresponding angles. A lot of times in doing this, it helps you to draw the F shape for corresponding angles. Because remember, this part of the F always has to be the transversal. So now we can see it must be L and M that are the parallel lines. So L is parallel to M by, and again, we're proving parallel lines, so that is the converse of the corresponding angles postulate. On a test or a quiz or even homework, yes, you have to say that you're using the converse of the corresponding angles postulate. Next part. Which lines are parallel if angle 1 is congruent to angle 2? All right, so now, looking up here, we have angle 1 congruent to angle 2. And again, it looks like those are corresponding angles. Again, it looks like they're corresponding angles. I can again draw that F shape right there. And so now this is the transversal, making A and B the parallel lines. Okay. So looking at the bottom here. These types of problems, they word the question differently, but really we're doing nothing different than what we did yesterday. Okay, even though they word it differently. They're saying, what is the value of x for which A is parallel to B? They're saying, what value of x makes those two lines parallel? Well, in order for those two lines to be parallel, what has to be true about our two angles we're looking at here? This angle there and this angle there. What type of angle pair are they? Same side interior. And think of it from yesterday's point of view. If the lines are parallel, same side interior angles are supplementary. If the lines are parallel, same side interior angles are supplementary. So now today we're flipping that around. We're saying, well, if they are supplementary, then the lines are parallel. And so what we need to do, in order to make those lines parallel, we need to find a value of x that makes those two angles supplementary. So even though we're thinking of it backwards, the math we do, the actual process of solving for x, is the exact same as yesterday. We're still just saying, all right, same side interior angles, supplementary, so 2x plus 9 plus 111 has to equal 180. So 2x plus 120 equals 180. We subtract 120 from both sides, so 2x equals 60, 60, and then divide by 2, so x equals 30. So there's our answer. And really, all you need to do is give me x equals 30, okay? But as far as answering the question, if I was to write it out in a proper sentence, I would say A is parallel to B only when x equals 30. Okay? If x had a value of 29, those lines aren't parallel. If x had a value of 5, those lines aren't parallel. Okay? Only when x is 30 are those angles supplementary, therefore making the lines parallel. Okay? So the wording of the question is different. The math behind the question is the exact same as the last couple days. Let's go to the back side of your notes. All right. I would like you and the people around you, your desk partners, to go ahead and find the value of W that makes C and D parallel. Okay. What are we coming up with? What type of angles do we have here? We have corresponding angles. Now, I'm seeing a lot of people setting up that corresponding angles are supplementary. I'm seeing a lot of 180 on your paper. Corresponding angles are not supplementary. What are they? They are congruent. If the lines are parallel, they are congruent, right? And so then, in order for those lines to be parallel, these two have to be the same measure. Okay, we got to watch out for that. So we're going to go ahead and add 2 to both sides. So then 3w equals 57. And now grabbing that calculator, we're going to take 57 divided by 3. And what do we get? 19. So when w equals 19, those angles are, those lines are parallel. Okay? Watch out for that. Make sure you know, are you dealing with supplementary angles or congruent angles? The only angle pair that is supplementary out of those 4 is the same side interior. Everything else is congruent. All right, taking a look at the example right next to that. We want to kind of talk through this one a little bit. So given that angle 1 is congruent to angle 2, you can use, now let's mark that down, it says given that angle 1 is congruent to angle 2, you can use the converse of the alternate exterior angles theorem to prove that line R is parallel to line S. Does everybody see that? Angle 1 and angle 2, those are actually alternate exterior angles that are on alternate sides of the transversal, line T, but on the exterior of our 2 lines R and S, so alternate exterior angles. We want to know what's another way to explain that R is parallel to S. So let's say we can't use the alternate exterior angles theorem, or the converse. How would we do that? How would we prove those 2 lines are then parallel by not using alternate exterior angles? Say what? 1 and 3 are corresponding. Okay. Okay, but how does that help us? How does saying 1 and 3 are corresponding help us prove that our lines are parallel? Now, I agree. There is a converse of the corresponding angles postulate, right? I'm assuming that's why you said that. So if we can show that angle 1 is congruent to angle 3, then we can say that R is parallel to S. Well, are we able to say that angle 1 is congruent to angle 3? Do we have that information? Again, what do you think? Right now, they've only given us that angle 1 is congruent to angle 2. Absolutely. Angle 2 and angle 3 are vertical angles, and we know that vertical angles are congruent. And so angle 2 is congruent to angle 3. The vertical angles theorem tells us that. And then we are able to say that angle 1 will in fact be congruent to angle 3. Angle 3 by our what property? How would I know? If I know that angle 1 is congruent to angle 2, and I know that angle 2 is congruent to angle 3, how do I know that angle 1 is congruent to angle 3? One's congruent to 2, 2's congruent to 3. So there is no substitution property of congruence. It is the transitive property of congruence, yes. That is the transitive property of congruence. All right. So we are able to go through and do that using corresponding angles. Well, guess what our proof is for today? They want us to prove the converse of the alternate exterior angles theorem, which means we can't use the converse of the alternate exterior angles theorem. So really now all we're doing is writing a formal proof for what we just talked about. We are given that angle 1 is congruent to angle 7. We want to prove that line L is parallel to line M. All right, well, we had just said that we could use corresponding angles. All right, well, in this diagram, what do I need to say then to get there? Okay, angle 1 and angle 5 are corresponding angles. So I don't need to state that in my proof yet. Okay? But what do I need to get there? In order for corresponding angles to be congruent, I need to say angle 1 is congruent to angle 5. Before I can get there, what do I need to say? Is that last thing we just talked about? Well, second to last thing we just talked about. We could go that route. You could say angle 3 and 1 because angle 3 is corresponding to which angle? 7. So rather than saying 1 and 5 are corresponding, we could say 3 and 7 are corresponding. We could do that. So I could say angle 1 is congruent to angle 3 by our vertical angles theorem. Yep. All right, so if I said angle 1 is congruent to angle 3, and I know that angle 1 is congruent to angle 7, then what else do I know? Nope, we don't want to go there. We don't want to put extra stuff in our proof that's not needed for our proof. 3 and 7 are corresponding. I don't need to state that right now. But I do need to say what about my corresponding angles? What do I need to say about 3 and 7? I need to say they're congruent. I need angle 3 and angle 7 to be congruent. Currently in my proof, I don't have that. But with the information I do have in my proof, can I say that? Yeah. Yes, I can say that angle 3 is congruent to angle 7. How? Because angle 7 and angle 1 are congruent. Yep. Angle 1 and angle 3 are congruent. Yep. So why is angle 3 congruent to angle 7? Transitive property of congruence. We had just discussed it in the last example. Transitive property of congruence. Okay, now I know that angle 3 is congruent to angle 7. So then what do I know? What are we trying to prove? L is parallel to M. What do we need in order to prove that? Well, look at the front side of your notes. In order to prove two lines are parallel, what do I need? Oh, so do we have, by the way, read the converse of the corresponding angles postulate.
If two lines in a transverse will form corresponding angles that are congruent, then the lines are parallel.
Yeah, so to summarize, if corresponding angles are congruent, then the lines are parallel. Do we have corresponding angles that are congruent? Yeah. Yes. Therefore, the lines are parallel. So says the converse of the corresponding angles postulate. Our corresponding angles, angle 3 and angle 7, are congruent.